Okay, in the next section of the notes, I want to discuss what are called arithmetic sequences. An arithmetic sequence is a sequence whose successive terms have a common difference. And so, for example, if I had the sequence 2, 5, 8, 11, etc., this would be called an arithmetic sequence because to get from each term to the next term, you are just adding 3, and that 3 is what we call the common difference. And so essentially what you need to realize is that in order to get any term, you just take the first term and you add one fewer of that many terms' differences. And that's essentially what this formula says right here in words. Is that if you want the nth term, you need to take the first term and then add n minus 1 differences to that first term in order to get the nth term. So we have an explicit formula, which I just circled. We have a recursive formula for arithmetic sequences. Both of these formulas are going to be given to you on a formula sheet, and so you don't have to memorize them. Obviously, you're welcome to, but you're not going to have to. I'll let you have those formulas. So example 6, for each of the following, find the common difference, the 10th term, a recursive formula, and the explicit rule for the nth term. And so looking at this particular sequence, -6, -2, 2, 6, 10, if it's not obvious to you what the difference is, then what you can do is take any term and subtract the previous term. So for example, if I take 10 minus 6, I'm going to get 4. If I take 6 and subtract the term before that, I'm also going to get 4. If I take 2 and subtract -2, that is also going to give me 4. And so you can see that no matter which term I take, if I subtract the previous term, in all scenarios, I'm going to get a common difference of 4. To find the 10th term, what we're going to do is we're going to take the first term in the sequence, which is -6, and we're going to add 10 minus 1 of the differences. And so this is going to give us the 10th term. And I'm basing that off of the formula that's back up here, this explicit formula, and the idea of arithmetic sequences. So -6 plus 9 times 4 is going to end up giving you 30. Okay, letter C, the recursive rule. In order to give this formula, we need to first give the first term, which is a sub 1 is equal to -6. And then a sub n is going to equal to a sub n minus 1 plus our difference. And that formula is going to be valid for n greater than or equal to -2. And then finally, the explicit rule, which will give me any term in terms of n. This is going to equal to the first term, -6, plus n minus 1 times the difference. I'm going to go ahead and distribute the 4. And so that's going to give me -6 plus 4n minus 4, and then collect the like terms so that I get 4n minus 10 as my explicit rule. Okay, letter B, we're going to do the exact same thing. And so you can take any term and subtract the previous term in order to get your difference. And so what you're going to end up with here is a difference of -2.5, which should make sense that it's negative since you see that the sequence is decreasing. Okay, letter B, we're going to get the 10th term by taking the first term, which is 12, and adding 10 minus 1 of the differences, which is -2.5. And so what you're going to end up getting here, you can use the calculator, obviously, to calculate that, which I'm going to have to do. 12 plus 9 times -2.5 is going to give me -10.5 for my 10th term. Okay, for the recursive rule, we're going to say that a sub 1 is equal to 12, and that a sub n is equal to a sub n minus 1 minus 2.5, and that formula is going to be valid for n greater than or equal to 2. And then finally, the explicit formula will start by putting the first term, which is 12, plus n minus 1 times the difference, which is -2.5. Go ahead and distribute your -2.5, so that'll be minus 2.5n, and then plus 2.5, which is going to end up giving you negative 2.5n plus 14.5. And that negative should be there with the 2.5n. Okay, now that we've talked about arithmetic sequences, let's talk about a different type of sequence called a geometric sequence. And a geometric sequence is a sequence where the terms have what's called a common ratio. Instead of adding a common difference like I did in arithmetic sequence, now I'm going to be multiplying by a common ratio. And so one example of this might be a sequence like the following: 1, 2, 4, 8, 16, 32, etc. And so what you can see is that I am multiplying by 2 to get to the next term. And so that 2 is what we call the common ratio. And so our formulas are given here. Again, you don't need to memorize those, but you do need to be able to write the formulas. And so let's look here at example 7. Given this first sequence in letter A, we want to find the common ratio, the 8th term, the recursive rule, and the explicit rule. And so if you look here, we've got 3, 6, 12, 24, 48. It's pretty obvious that the ratio is 2, but if you're not sure, you can take any term and divide by the previous term. And so 48 divided by 24 is going to give you 2. If you took 24 and divided by the term before it, that would also give you 2. If you took 12 and divided by 6, which is the term before that, you would also get 2. And so the common ratio for this particular sequence is 2. Now, to find the 8th term, that's going to be a sub 8. We start with the first term, which in this case is 3, and we multiply by the ratio raised to the 8 minus 1 power. And so this is going to end up being 3 times 2 to the 7th power, which is 384. All right, the recursive rule is going to be a sub 1 is equal to 3, and then a sub n is equal to 2 times a sub n minus 1, and that formula is going to be valid for n greater than or equal to 2. And you need to write this part because that tells you when to start using particular values of n. So please make sure that you don't leave that part off. Okay, and then the explicit formula is going to be a sub n is equal to a sub 1, which is 3, times r to the n minus 1. And there's no way to simplify that. Please don't write it as 6 to the n minus 1. You can't multiply the 3 and the 2 because the 2 has an exponent on it. Okay, in letter B, it might not be totally clear what the common ratio is, and so in that case, I would suggest for you to start dividing. And so r is equal to negative 1/4 divided by 1/8. You can use your calculator to do that if you need to, and you're going to end up with negative 2. You would get the same result if you took any term and divided by its previous term. And so our common ratio here is going to be negative 2. And that's going to make it easy to find our 8th term because that's just going to be the first term multiplied by our ratio to the 8 minus 1 power. And when you put that to a calculator, what you're going to get is negative 16. Our recursive rule, we start by listing the first term, which is a sub 1 is equal to 1/8, and then a sub n is equal to negative 2 times a sub n minus 1, and that's valid for n greater than or equal to 2. And then finally, our recursive rule will say that a sub n is equal to a sub 1, which is 1/8, multiplied by our ratio of negative 2 raised to the n minus 1 power.